In this video, we're going to explore the last of our special parallelograms, the square. While all of the parallelograms are special, the square has a little something extra going for it. Now, because a square has 4 right angles, that automatically qualifies him as a rectangle. Because a square has 4 congruent sides, that automatically qualifies as a rhombus. And in addition to being both a rectangle and a rhombus, the square is also a kite, but you're going to hear more about the kite in the next video, so I'm going to save that for later. But because a square is a rectangle, it has all the properties that a rectangle has. Because he's a rhombus, he has all of the properties that the rhombus has. So what I like about the square is that because he falls under the umbrella of these other 2 figures that we've already studied and paid so much attention to, we already know everything there is to know about the square. So I don't know, that's what I think is really cool about the square. So in example 1, we're given square ABCD with those attributes. They want us to find the value of x, and they also want us to find the length of the diagonal of the square. So because there's no picture, the first thing that I'm going to do is go draw a nice picture of this square. Remember, when you label the vertices, you either need to proceed around in a clockwise fashion or a counterclockwise fashion. The choice is up to you. But side AB has length 2x minus 14, and side BC has length x plus 15. So because a square is a rhombus, and I know that all the sides of a rhombus are congruent, I know that all 4 sides of the square are congruent, which means the length of AB and the length of BC are equal. So the equation that I'm going to write here, 2x subtract 14, is equal to x plus 15. In order to solve, I'm now going to go subtract an x from both sides. To undo subtracting 14, I'll add it to both sides. So the value of x for this particular square is 29. Which means that the length of side BC is going to be 29 plus 15, or 44. And the length of side AB is going to be 2 times 29 minus 14, or 44. And these two both came out the same. If they had come out differently, I would have known that I made a mistake. All 4 sides of the square measure exactly the same, 44 units. So in this question, we were directed to find the value of x, done, and find the length of one diagonal. So I'm going to go ahead and draw in diagonal AC. Because a square is a rectangle, it has 4 right angles, which means angle D in this particular picture is a right angle. So in other words, what I'm looking at here is I'm looking at an isosceles right triangle where I know that the 2 legs of my right triangle measure 44, and I'm trying to determine the length of that hypotenuse. Now, I can do one of 2 things, or use one of 2 strategies in order to figure this out. I could do a little bit of Pythagorean theorem because I have a right triangle where I know the lengths of 2 sides, and I want to determine the length of that hypotenuse. Or I can say this is an isosceles right triangle, and I remember that my rule for the isosceles right triangle says the length of the hypotenuse is equal to root 2 times the length of either leg. I'm going to use the rule because it's a shorter, faster, easier way to figure out the length of the hypotenuse. But if you've forgotten the rule, a squared plus b squared will get you to the right place just as effectively. So I now know that the diagonal has length 44 radical 2. The second question also deals with the diagonals. It says, find the length of the side of a square whose diagonals measure 12 centimeters. So again, I'm going to go draw a nice picture so I'll have a visual of what I'm looking at here. Because every square is a rhombus, I know that the diagonals are perpendicular. Because every square is a parallelogram, I know that they bisect each other. And if the diagonals each measure 12 centimeters and they bisect one another, that means each piece of the diagonal has to be 6. I'm trying to determine in this particular example the length of one side of that square. So I'm going to make that x. And then what I'm going to do is I'm going to take a look or pull out that triangle. So I'm going to isolate that triangle where the right angle, or the angle's a right angle. Each of the legs has length 6. So again, this is another question where I'm set up perfectly to either find the length of that, the length of x by using a squared plus b squared equals c squared. Or again, if you remember that rule that in the isosceles right triangle, the length of the hypotenuse is equal to root 2 times the length of a leg, that's a nice little shortcut that you can use in solving these types of problems. So x is equal to 6 root 2, or in other words, the length of the side is 6 square roots of 2. I like using that rule because it's a more efficient way to arrive at the correct answer. But if you're more comfortable and confident using the Pythagorean theorem, then by all means that'll work just as nicely. Number 3 is a very similar type of question. It says find the length of the side of the square where the diagonals measure 16 centimeters. So again, I'm going to draw a nice picture so I have a visual of what it is that I'm looking at. Because every square is a rhombus, the diagonals are perpendicular. Because every square is a parallelogram, the diagonals also bisect each other. So each of these little pieces of the diagonal is therefore 8. And again, we're trying to find the length of the side of the square. I'm going to call that x. And I'm going to go ahead and isolate one of these right triangles. So I'll pull that little fellow right out of the picture. So I have this right triangle, which is an isosceles right triangle where each of the legs has length 8. And again, I'm looking to find the hypotenuse. So again, if you're a big fan of Pythagorean theorem, he will definitely help you get the job done. I'm going to use my special right triangle rules because it's just a little bit more efficient. So root 2 times the length of a leg. So x is equal to root 2 times 8, or in other words, 8 root 2. So the length of one side of the square, 8 root 2. If you know the rhombus well, and you know the rectangle well, the square is going to be a cinch because all of the properties that we used for the rhombus and the rectangle, we're just now going to continue to use in order to solve problems that involve the square. All right, so there you have it in a nutshell. I do want you to take some time, just like every time you watch a video, take some time to think about what you've seen, think about what's important, think about what you're going to need to be able to recall and use, both in your classwork and on your quizzes and tests. Summarize that information up at the top of page 24, and then see if you can apply what you've learned by watching this video in order to solve the questions on page 24.